All right, welcome. Today we're going to break the world down to its most basic parts. We're talking about the fundamental building blocks of, well, everything you see and touch. So let's jump right in. I mean, seriously, look around. The device you're watching this on, the chair you're sitting in, the air you're breathing, it all seems so complicated, right? But what if I told you that pretty much all of it can be sorted into just two huge rival families? Yep, that's it. Underneath all the complexity, you've basically got metals and nonmetals. And they have completely opposite personalities, which is what dictates, everything about how they act and what we can use them for. So, let's get right to it. We're going to put these two groups head to head and really see what sets them apart. Think of it as the ultimate chemical showdown. First round, looks. Okay, metals are definitely the show-offs of the periodic table. They're what we call lustrous, which is just a fancy way of saying they're shiny. Nonmetals, not so much. They're usually pretty dull. Just picture the bright gleam of a fresh coin versus, say, a lump of charcoal. Big difference. And that shine is a big deal. Gold and silver aren't just valuable because they're hard to find. That natural shimmer is what has fascinated people for centuries. It's what makes them perfect for jewelry. It's really their signature move. Okay, next up, how did I handle a little pressure? Well, metals are malleable, which means you can hammer them into super thin sheets and they won't break. They're also ductile. You can stretch them out into wires. Nonmetals are the complete opposite. They're brittle. If you hit one with a hammer, it's just going to shatter. And get this, that ductility can be pushed to some insane limits. A single gram of gold, which weighs less than a paper clip, can be stretched into a wire that's over 2 kilometers long. That is just incredible. 2 kilometers. So what about moving energy around? Metals are fantastic conductors of both heat and electricity. It's why all our pots and pans are metal, and obviously so are our electrical wires. Nonmetals are poor conductors. We call them insulators. You know this from experience, right? Try stirring a hot soup with a metal spoon, and you'll feel that heat travel right up to your hand. A wooden spoon? No problem at all. But, this is where chemistry gets really fun. Just when you think you've got the rules all figured out, you run into the exceptions. And there are always elements that just love to break the rules. Let's take mercury. It's a metal, no doubt about it. But at room temperature, it's a liquid. It flows. And then you have bromine, a nonmetal that's also a liquid. And even good old lead, a classic metal, kind of breaks that shininess rule by being pretty dull. And the biggest rule breaker of them all might be graphite. Now, graphite is just a form of carbon, which is a classic nonmetal. And yet, it conducts electricity like a champ. It's so good at it, in fact, that we use it to make batteries and electrodes. It's a nonmetal doing a metal's job. All these rebels actually point us to this really cool third group, the metalloids. These elements, like silicon, are the great compromisers. They have a mix of properties from both sides. They're not great conductors, but they're not insulators either. They're semiconductors. And that one little in-between property, that's the reason silicon is at the heart of literally every single computer chip on Earth. So we've talked about their properties, but why does any of this really matter? Well, it's these unique traits that let us do everything from building skyscrapers to powering our homes, and even growing our food. It's really all about picking the right element for the right job. You need to move electricity from a power plant to your house? Copper's amazing conductivity makes it the obvious choice. Building an airplane? You need something strong but also light, so you go with aluminum. See? Each property has a purpose. And we can't forget the nonmetals. Look, if metals build our modern world, the nonmetals build, well, us, life itself. We breathe oxygen. Our bodies are built from carbon. We make our water safe to drink with chlorine. They might not be shiny, but they are absolutely 100% essential. But for all their strength, for all their usefulness, many metals have this one, constant, silent enemy, a slow chemical attack that's always trying to turn them back into dust. We're talking, of course, about corrosion. And you've seen it everywhere. Rust. It's the most common type of corrosion. You can almost think of it as a fire in super slow motion, one that takes strong, solid iron and turns it into that weak, flaky, reddish powder. It's this constant battle between our engineering and the laws of nature. So what's the recipe for this destruction? It's actually incredibly simple. You only need 3 things. You start with iron, you add some oxygen from the air, and you add a little bit of water or moisture.
When those three get together, bam, you get rust. Of course, we're not just going to let that happen. We've figured out ways to fight back. The easiest way is to just put up a barrier. We coat iron and steel with paint or oil or even a thin layer of another metal, like zinc. That process is called galvanization, and it basically puts a protective shield around the iron to keep the water and oxygen out. But this whole fight against rust brings us to one last absolutely amazing mystery. What you're looking at here is the Iron Pillar of Delhi. It was forged in India over 1,600 years ago, and it's been standing out in the open, exposed to the weather, for all that time. And here's the crazy part, it has barely rusted. It's a masterpiece of ancient chemistry, made with some unique formula that's protected it for centuries. And to this day, we still don't fully understand how they did it. It's just a perfect reminder that no matter how much we think we know about the elements, they've always got more secrets to share. Makes you wonder, what else is out there that we've forgotten? Thanks for joining me on this one.